quiz today, don't we? We do? Yeah. Yeah. We'll do the section quiz at the end. Is that okay? Okay. All right, so, the green flashing corners up here, that just lets you know that it's recording. All right? Today is October 27th, Tuesday. All right, we are going to sketch a graph of this. X cubed plus 1 times x, yoo-hoo, times x plus 3, all over x squared plus 5x plus 6 over x minus 2. Yikes. All right, now, I have partially factored this for you. All right, do you see anything up in the numerator that's going to factor further? Yeah. Zoe, what factors further? The x cubed plus 1, absolutely. And can you go ahead and factor that for us? Plus 1, exactly. That's the SOAP factoring. Same sign, opposite sign, always positive. And then this x plus 3 is still here. X plus 3. And in the denominator, that quadratic factors. Ryan, can you factor that one for us?
Yeah, x plus 3, x plus 2.
X plus 3, x plus 2, and that original x minus 2 is still there. All right, now what do you see? Simani, what do you see? The x plus 3 divides out, sure. Oh, what's that telling us? Since we crossed out that x plus 3, there's a hole in the graph. And that hole is going to be at -3. We'll figure out the y coordinate here in just a minute. I want to go ahead and simplify this the rest of the way. X plus 1 times x squared minus x plus 1 all over x plus 2 times an x minus 2. All right, now let's go back to our hole. We know the x coordinate of that hole is -3. We can take that -3 and we have to plug it into the simplified form. So it's got to go right up into here. Don't multiply that out first, just plug in the -3 as is. So a -3 into here. -3 plus 1 is -2. And then, let's see, a -3 squared, 9, minus a -3, 12, plus 1, 13, over, and then a -3 down here, that's going to be a -1 times a -5. So that's -26 over 5? -26 over 5? Yeah. So that's going right here. -26 over 5. There's the y coordinate of the hole. All right. Now go back to where we simplified the factors that did not cancel out, the x plus 2 and then x minus 2. What do those produce in the graph? Vertical asymptotes. Vertical asymptotes are going to occur at x equals -2 and x equals 2. Okay. Horizontal asymptote. All right, we need to compare the degree of the numerator with the degree of the denominator. And you can go right here. The degree of the numerator, if you were to multiply all that back out again, what degree would it be? It's an x cubed, a degree 3. How about the denominator? X squared. So an x cubed over an x squared. Is there a horizontal asymptote? No. But is there an oblique? Yes. there is an oblique asymptote because the degree of the numerator is exactly one more than the degree of the denominator. Alright, we're going to have to find that, which means we're going to need to be able to do division. Can we do synthetic division? No, because the numerator was a degree 3 and the denominator was a degree 2, which means we can't do synthetic. We have to do long division. In order to do that long division, though, you're going to have to multiply all this stuff back out. Okay, don't panic. Where did this x plus 1 times this x squared minus x plus 1 come from? Wasn't that x cubed plus 1? So we're looking at, when we multiply it all back out, that's x cubed plus 1 over, now the denominator, that's easy. That's an x squared minus 4. Wasn't so bad. Alright, let's set up this long division. X squared minus 4 into x cubed, don't forget your placeholders, 0x squared, 0x plus a 1. What do we have to multiply to get from x squared to an x cubed? By an x. We multiply, that's going to give us x cubed minus 4x. Subtract. X cubes go, we have 0x minus a minus 4x. 4x plus 1. Okay? Which means that, and then that's it, we're done. X squared won't go into a 4x. So we know that this y can be rewritten as that quotient x plus that remainder, 4x plus 1, over the divisor, x squared minus 4. So where's our oblique asymptote? Y equals x, right there. That's the oblique asymptote. That's linear, so we know it's an oblique asymptote. And that oblique asymptote then is just y equals x. All right, a couple more things that we need to find to graph this. What else do we need to find that's going to help us graph this? Zeros. And Matt, how do you find zeros? Okay, zeros of the numerator. So x plus 1, what's that 0? Negative 1. Okay, how about this? X squared minus x plus 1. Will it factor? No, it doesn't factor. Do you also remember that I told you when we factor cubics, using that SOAP factoring, that this, the quadratic that's left, has no real solutions? Do you recall that? If you've forgotten that, that's all right. Let me show you something else. Take this, x squared minus x plus 1, and let's just come up here and let's think about this and find the discriminant. Do you remember the discriminant? B squared minus 4ac. We talked about this last week. If the discriminant can tell you how many solutions there are and what kinds there are. So let's sub in, this is going to be a negative 1 squared, which is 1, minus 4 times a times c. So our discriminant is negative 3. Yes? Everybody okay? Yeah? Which means how many solutions and what kind? 2 complex. That are going to have an imaginary part. 2 complex solutions that have an imaginary part. Okay, so what does that tell us about here where we're graphing on the real numbers? That's it. That's the only 0. The only 0 happens at x equals -1, which means we have a point at -1, 0. All right, what else do we need to find? Y-intercepts. And that's just plugging in x equals 0. And look up here so you know what I'm pointing at. You can plug in x equals 0 into this original, into this simplified factored form, or into this form down here that's all multiplied out. Those 3 for x equals 0 is going to give you the same thing. Which one's easiest to plug into? Probably the last one, I think. And we get -1/4. All right. Okay, grab a colored pencil if you'd like. Absolutely grab a ruler because we want to have nice straight lines here when we draw our asymptotes in. Okay, vertical asymptotes at -2 and at 2. Okay. Let's see, there was a hole at -3, -26/5. -26/5 is, as a mixed number, -5 and 1/5. There's a hole right there. Got my hole in, got the verticals in. I need to put my oblique asymptote in. And the oblique asymptote is y equals x. Again, I like to kind of follow that slope all the way out for the entire length of the grid. And then I make sure that I don't like twist my ruler a little bit and get off. There's that oblique asymptote. We have a 0 at x is -1, so here's a point right here. When x is 0, y is -1/4, so that's right here. Everybody okay? All right, now let's start graphing this thing, and we have enough actually to graph this. I'm going to start kind of here in the middle. You know you got to reach these, come toward these vertical asymptotes in the middle. You can use this 0 here and this point there. Clearly those need to connect, so this is going to have to come down this way. I know it can't turn back up after I hit this the y-intercept, because I would have to cross the x-axis again, and I can't do that. Okay? This piece now from this -1, it could realistically turn back down and go this way, but this -1, 0 came from that x plus 1, which was a degree 1, so we know that that 0 has to cross through the x-axis. Does that make sense? So this one has to come back up this way. Now, to draw the rest of this, we're going to use the oblique asymptotes, the vertical asymptotes, and this idea that we cannot cross the x-axis. Again, we can only cross the x-axis once. Okay, I have this hole. You have to hit that hole. So we're going to have something, oops, like that. It's going to run into that hole on one side and come out on the other side, approaches the vertical asymptote, and it's going to get closer to this oblique asymptote. Alright, that gives us the piece to the left side of -2. How about to the right side of +2? Here's your options. You've got this piece down here, or it could be up here. Could it be this piece down here? No, why not, Ryan? Yeah, can't hit the x-axis again, and we would have to hit the x-axis again if we had this piece. So it has to be this piece up here. We are not really sure where it is. Again, we're just doing sketches. So it looks something like that. Okay, so far? Are we good? All right, can you take out your calculator, please? Do you need to borrow one?
Yeah.
Anybody else need to borrow a calculator? Okay, listen, this is what I'd like you to do. One of you type in each pair. Okay, so Monty, you and Kevin gotta join up again here. One of you put the original in. The other person put this simplified form in after we factored out that the x+3. Okay, so one of you do the original and one of you do the simplified form. Me. Which one do I need? Okay, you put the simplified form in and I'll put the original in. Okay. Oh, that makes sense. Okay, do you agree? You get the same graph? Compare your graph with your neighbor. What? It should look like that. If it doesn't look like that, then something's wrong.
We both got the same
That is
thing though.
hysterical that the both of you did something wrong.
It's the same
Yeah.
graph. Same graph.
Okay, because order option number 9. If you just put it in a fraction, then you took this, divided by that, then multiply with that. Can you see that? You can clean that up just fine. what I want you to take a look at. So that matches, yes? We match? Pretty darn close, right? Except for 1 point, exactly. So now here's what I want you to do. Go to second calc, do a value at, where was our hole? Negative 3. Negative 3.
Y equals the.
Okay, I typed in the original one. Did you get an answer? Yeah, you got it. Okay, so some of you got, like mine, y equals nothing. If you typed the original, you got y equals nothing, right? Because the original function is not defined there. But if you typed in the simplified form, you got a y value of negative 26 over 5, right? Which is that. Because this simplified form, that one is defined when x is negative 3. The original is not defined when x is negative 3. Does that make sense? Okay, let me show you something else. If you have the 84 plus, not the color, change your window to negative 9.6 to 9.6. Wait, let me see. No. Oh, it's negative 9.8, I think. Negative 9.8 to 9.8 could be. It's either 9.6 or 9.8, and I can't remember which one it is. But I'm looking for something to occur. And I'll tell you in a minute if I did it right. Trace. Nope, it's 9.6. You should be able to see the hole pop up. No, it's not showing. Bummer. Bummer. All right, never mind then. I tried. There's times that you can change the window just right. You'll be able to get that hole to show up. Where you'll see where one of the pixels won't turn on. You'll see that hole. But you have to mess around with the window. And I thought it was 9.6 that would show it, but it's not. And I got to figure that out. See? That should do that. And I'm going to have to mess around with it. Maybe, yeah. Okay. That's it for today. Are we good? Yeah? All right. The rest of the time is yours. Thank you very much.